we have a car tire here, and then we're just measuring the pressure on the car tire. So we have a pressure gauge here. The pressure gauge is reading 29 psi A or psi G? Psi G. Now the thing is if this were reading 0 psi G, then no air will come out. No air will come out of the tire because the pressure, atmospheric pressure, and the tire pressure are equal and opposite. And so it's empty, basically. But it's not really empty because there's still 1 atmosphere of air in here. Well, is it really 1 atmosphere? Well, it's a little bit more than 1 atmosphere because 1 atmosphere is 29.94 inches. We have 30.09 inches, so this must be a sunny weather day. 30.09 inches of absolute. And so what this is psi G, and so the question is how much, psi A is it? And but the psi A we know is 30.09 inches of mercury. And so what we're going to do is we're just going to use a little bit of dimensional analysis here. 30.09 inches of mercury, we just use the conversion factors here. We don't have to have the inches, the conversion factor, memorized necessarily because we know that there are 2.54 centimeters in an inch, and then there are 10 millimeters per centimeter. And so that'll tell me how many millimeters of mercury I have. Or I could use the 29.94 conversion. But since I don't have that one memorized, I don't want to have a whole bunch of conversion factors memorized. I'd like to use the minimum, or have the minimum number of conversion factors memorized and just string them along. And so in this case, I don't really have to memorize a new one, which I don't want to do, because the new one I have to memorize is this one. But the problem with this one is it's only good to 4 sig figs, because this is not exact. So 29.92 inches per atmosphere. In other words, 760 millimeters is 29.92 inches in length. And so let's go ahead and do this one here. It's going to come out to a little more than 760 because the pressure is a little higher. When you listen to the weather report, typical pressure is 29 inches around there. So this is 30.09 inches. 30.09 of atmospheric pressure times 2.54 to convert it into centimeters times 10 to convert it into millimeters. And so we got a pressure of 764.28 millimeters of Hg. But you know what? I don't want millimeters of Hg, so this is an intermediate answer here. I shouldn't have stopped here because I should have went to PSI. Now the conversion for PSI, we're just going to use 14.70 psi per atmosphere. Actually, I need to go to atmosphere. So, continuing on here, this one you have to have memorized. That is, 1 atmosphere is equivalent to 760 millimeters of mercury, and then 14.70 psi per atmosphere. So this is the way I would have strung it along, except I wouldn't have stopped here. I wouldn't have done this intermediate. But I stopped here just to compare. 30.09 inches of atmospheric pressure is actually 764.28 millimeters of mercury, and normal pressure is 760. So this is a little bit above normal. All right, so I'm not going to clear it in my calculator. It's 764.286 divided by 760. Converted into atmospheres times 14.7 to convert it into psi. So it's going to be slightly above 14.7. It's going to be 14.7. Now, how many sig figs do we allow? How many sig figs is this? 4.
3. 2. 1. Okay, so infinite.
Infinite. This is infinite? Infinite. This one's intermediate, so we'll hopefully I didn't round it, etc. Let's leave it in my calculator. This one is infinite. This is infinite?
Yeah.
This is not infinite. This is
No, that's by definition, right?
no, not by definition. This one comes out to like, as I recall, 14.69, et cetera, rounded to 14.70. This one is going to be 4 sig figs. So like I said before, I want to see the drop digit. And so at least write that. The drop digit in this case is going to be 2. There's a 2.9. I'll write some extra. This is going to be PSI. But you know, this is not our final answer, so I'll go ahead and carry extra digits here. This is going to be PSI. What is this? A, PSI A. All right, so this is our barometric pressure. Our barometric pressure is 14.78 PSI A. And so what that means is that this, you know, this is not really 29 PSI. This is really 29 plus 14 point. And so if I want to get the PSI A here, I am going to have to go 29 plus 14.782 PSI. This would be PSI G, this is PSI A here, which is going to give me 43.782 PSI A. And so we're converting from a PSI G to PSI A. Does that make sense? In other words, this is not really 0. This is really 14.78. If this is really 14.78, then this is not really 29. It's actually 29 plus the 14.78. In other words, 43.782. Does that make sense? Or not really?
So that's similar to the way they solve the problem that originated with that 29.
Well, we're not done with the problem yet.
Oh, we're not done.
We're going to be done in a minute. Well, another way of thinking about this is this. If you have a scale at home, right? And the scale's reading 0 pounds on the scale. It's reading 0 pounds because you adjust it. It's what we call an arbitrary 0. You set the 0, right? When you set the 0, you set it to 0 because actually there's a metal plate on here, a glass plate or some plate on there that you stand on. That plate weighs something. And this is the same function as tare. When you tare the balance in the lab, you're zeroing the mass of the plate on there. And so that's an arbitrary 0, but sometimes we don't want an arbitrary 0. Sometimes we want the absolute. And so how much does it really weigh? And so what we need to do is, if I want to know the total mass on the balance here, I need to know the mass of the plate plus the mass of the person standing on there. And that's going to give me the total mass of the balance. And it's the same thing here. If I want, you know, this is like tearing it. So I'm zeroing it here, and I'm just measuring the mass of the air. But what I want to do is I want to measure the mass of everything, so I'm going to have to calculate how much this weighs at 0, since it's arbitrarily set 0. And so this is how much the 0 weighs. This is like the weight of the plate there. And so I'm adding the weight of the plate to the weight here. And so this gives me the total weight on there. And so that's what we're doing with the gauge pressure. We're just figuring out what the true pressure is. And so the true pressure would be on an absolute gauge. On an absolute gauge, what we're going to have is an absolute 0 pressure. And so this is really 0 PSI A. And then our true pressure in the tire at 29, when our gauge is reading 29 PSI G, the true pressure is actually 43.782 PSI A. So 43.782 PSI A is the same thing as a 29 PSI G. Does that make sense? Or not really? No?
So PSI G and PSI A, like, how
No, well, it's the PSIG. We're adding the offset here. We're adding whatever this is, you know, the zero. It gets even trickier because the zero changes depending on what atmospheric pressure is. So it's going to define what zero is. And so let me see if there's some kind of animation. If there's
G. Pounds per square inch gauge unit of
all
pressure.
right. Let's see if this was maybe the audio, maybe this.
PSIG.
Forget it. Machine. Okay.
As it concerns.
How about this guy? Maybe he can explain.
Hi everyone, my name is George Corley. I've often been asked to explain the difference between PSIA and PSIG. So here's the difference as I see it. On this slide, you're looking at the Earth with a thin blue ring around it. That's the atmosphere surrounding our home. The atmosphere has a mass and the Earth has a mass. And so they cling to each other by a force called gravity. It is said that if two ships were left adrift on the ocean, they would be pulled together. Two masses will always be pulled together by gravity. It's a good thing because our fellow on the right would fall off the Earth. The moon is pulled toward the Earth and the Earth is pulled towards the sun by each other's gravities. Because they're spinning around each other, centrifugal force keeps these masses apart just right, similar to swinging a bucket of water over your head. Let's hope the spinning never stops, else we could be in a lot of trouble. Dr. David Suzuki once said that if the Earth was the size of a basketball, the atmosphere would have the equivalent thickness of saran wrap. We don't have much. That's why atmospheric pollution is so scary. Although the atmosphere is only about 70 miles or 113 kilometers high, it has been calculated to have a mass of approximately 5 sextillion tons. That's a 5 followed by 15 zeros. But if we were to imagine a 1 inch by 1 inch column of atmosphere from sea level to the top of the atmosphere, the mass of that column would be 14.696 or 15 pounds. This is arrived at by dividing the mass of the atmosphere by the entire area of the Earth's surface. So every square inch exposed to the weight of the atmosphere will be subject to a pressure of 15 pounds. In other words, it can be said that every surface at sea level will be subject to a pressure of 15 pounds per square inch or 15 psi. Obviously, the pressure will be less at a higher level, say on top of the mountain, since the column will be shorter. Air has an affinity for water. We know that at times the air can be more moist than at other times. But for water vapor to enter a column of air, some air must be displaced because no two entities can occupy the same space. It is interesting to note that the mass of the water vapor entering the column is less than the air displaced. Hence, the now moisture column will weigh less than when it was dry. If a weather forecast indicates a low pressure coming into the area, that air will most certainly contain a lot of moisture. Here we have an open plastic bag. the bag has no tendency to explode or implode, since the pressure on each square inch of surface is equal, both on the inside and the outside. Does this mean that there is a pressure of 15 psi exerted on every square inch of our body? Yes, it does. But there is an equal amount of pressure exerting outward as well. If an astronaut didn't wear a pressure suit, maintaining a 1 atmosphere pressure while floating in space, his or her body would explode. The one exception is our pleural cavity. As we expand our chest muscles, thus increasing the size of our lungs, the pressure inside drops and the atmosphere rushes in to fill the void. We call this breathing in. A vacuum cleaner is designed to remove the atmosphere from within itself and discharge it elsewhere, say a dust bag. New atmosphere then rushes in, pushing any dust or other material in its path ahead of itself. So in fact, those little dust bunnies are not being sucked in, they are literally being pushed in. Here we have an empty gas cylinder equipped with a pressure gauge which reads 0 psig, because it's empty. As with the empty plastic bag in the previous slide, although the cylinder is empty with the valve open to the atmosphere, there is a pressure of 15 psi both inside and outside of the container. Now let's close the valve and take the cylinder above Earth's atmosphere. Here we have no inward pressure on the container, but since the valve was closed before we left, we still have 15 psi pushing upward on the cylinder's wall. Now let's open the valve and allow the trapped atmosphere to escape. The cylinder is now subject to absolutely no pressure whatsoever in either direction. Now let's close the valve and return to the Earth's surface. While the valve remains closed, the cylinder's internal pressure will be absolutely zero, a perfect vacuum. And it will now have a tendency to implode since it is once again subject to an inward pressure from the atmosphere of 15 psi. If we were to now open the valve, the atmosphere would rush into the cylinder, much like the action of the vacuum cleaner. When measuring pressure, we tend to measure any pressure above 1 atmosphere. Any pressure below 1 atmosphere we classify as a vacuum. These pressures have values expressed on the PSIG scale with references to the pressure of 1 atmosphere as being 0.0. In fact, the absolutely true scale should reference a point where there is no pressure whatsoever, for instance, above the Earth's atmosphere. And that point should be 0.0. In this case, the values would be expressed in PSIA. There are gauges similar to the one shown on the screen which can indicate the entire true pressure beginning at 0 PSIA, or 30 inches of mercury vacuum, while most other gauges only measure pressures above atmosphere. In conclusion, regarding pressures above 1 atmosphere, PSIA readings are 15 psi greater than PSIG readings. So this is the difference between PSIA readings are 50.
Let's just take a look at the gauge here. If you look at 0 here, then we got negative, which would be vacuum, and positive. And so, in other words, if we sucked it all out, we're going to have a perfect vacuum at 14.7 or 15 psi. And so all we have to do is we're just resetting the scale. And so if we just twist this, okay, if we just twist it, because here we have the absolute 0, here we have the arbitrary 0. So we're going to just take the faceplate and twist the 0. If we twist the 0 so that it matches the absolute 0, then what is the pressure reading? And so all we're doing here is, and the difference between the two gauges is very simple. The difference between the two gauges is where they print the zero. That's the only difference. And so let's take a look here at what we're doing in this particular problem. What we're doing at this particular problem is this. This zero here is 0 psi G. The gauge here is reading 29 psi G. 29. And so what we want to do is we want to rotate this zero so it matches absolute zero. And so if we rotate this zero to match absolute zero, then everything's going to be offset. And that is, this is no longer going to read 29. And so if I rotate it, it depends on what the pressure is today. The pressure turns out to be 14.78. 14.782 psi A. And so what that means is that this zero is arbitrarily set at 14.782. So what I need to do is I need to rotate this minus 14.782 backwards. And so if I rotate this minus 14.782 backwards, then the zero matches the absolute zero. If the zero matches the absolute zero, this is no longer going to be 29. This, which was at 29, is going to be 14.78 here. And then the scale, the needle's still going to point here, but the scale's going to point there. So this is going to be minus 14.782. So what I did was I wanted to know where this pressure is going to be. So all I did was I took the 29 and then added the 14.782. Does that make sense? Maybe.
Well, Professor, they're using 15 instead of 14.78.
They're just rounding it.
Okay.
That's all. Are we out of time? Oh boy. All right. I didn't make it that far, so I'll go continue tomorrow.
Sorry, Mr. Shabbat.
Yeah.
So what you do is that instead of measuring to the left, you just measure the bottom on the right.
All I did was I took the plate, the plate, and then rotated it so that there's no negative. So zero is really zero. Here, let me actually. It would be easier if I showed the gauge. Well, see, since you've been attending this course, see if we can do a transfer to 20. If I have one student transfer from 20 to 4, so you might be able to do a transfer. Go talk to the 20 instructor so you can do 4.
I really want to counselor. I don't know what's happening.
Well, it depends on what nursing program. Some nursing programs want 4, 1, like that, but going to nursing home here. All right, then this is the one. Yeah, this is only for you.
That's the amount that's the gap difference.
Well, anyway, talk to the counselor or talk to Chem cleaning instructor. See if they're still if you can attend Chem 4.
Brick of lead. Okay, that has way too much.
Oh my god, I forgot about mine.
Well, good luck with that.
It had way too.
Oh my gosh. I am weak. I'm weak.
And they say gold is heavier than.
Oh yeah, it is. A
You
brick
you added it last.
is weight. It's almost twice than that.
Yeah, I
And
have.
it would be the same size.
I'll give it to you tomorrow.
Oh, isn't that scary?
That's
That's what people say. They got them changed. Like bricks. Yeah, it's crazy.
I can only imagine the bank robbery movies where they
Yeah,
have, where
that's
they're
so
rolling out like
funny.
carts of gold. I'm like, how can you roll that?
You can't
much
move
gold?
that easily. I have a question.
Okay.
I wanted to know if my thought process on this was correct, because I didn't do the conversion to the PSI. I just went from the 30.09 and then used this conversion to 1 ATM, ATM to PA, and then the PA to KPA, and got this. And then
Okay.
did the same for this one, and then just added them at the end.
Yeah, that's fair.
Okay, that makes me feel better. First, I was like,
Thank you,
Professor.
Good.